Alright, so I think I'm recording. Let's take a look at this problem, problem number 3. In science class, an experiment showed that the stated temperature differs from the actual temperature by exactly 1.5 degrees. Write and solve an absolute value equation to find the minimum and maximum actual temperatures when the thermometer reads 87.4. Now see, I think the minimum maximum should actually be stated. It should read stated because if the thermometer is reading 87.4, unless we're saying this thermometer has some inaccuracy, maybe that's how they want us to interpret it. That this thermometer sometimes it lies a little bit. It's a cheap thermometer. You picked this up on sale at the dollar store or something like the Dollar Tree. Um, so maybe that's the stated temperature differs from the actual temperature um, by exactly 1.5 degrees. I think in class I read that different. Now I'm reading it a little bit different. If I look at this as the stated, and it wants the min and max to be actual temperatures, yeah. So what's going on here? Let's let x be the actual temperature. We could have let it be T, and it has units of degrees, but it's really not telling us whether it's degrees Fahrenheit or degrees Celsius. All right, so um, the thermometer is telling us 87.4, but we know that thermometer may not be NASA accurate. It might not be, like I say, it's maybe just some cheap thing from the Dollar General. But it's kind of close. It's within 1.5 degrees. So here's the equation that we want to solve, and it will give us the minimum actual temperature and maximum actual temperature. So yeah, I'll have to tell you in class that I maybe misinterpreted um, that when we did it, or maybe, I don't know. Maybe I did do it right. I can't remember. I think I've worded it. We're going to get the same answers, but my understanding of the problem was slightly different than it is right now. All right, so let's take 87.4, add that to both sides of this equation. So I'm getting 85.9, and that's in degrees, or I'm getting 88.9 degrees. So there's my two answers. And like I say, I'm now interpreting this. It says that it wanted the min and max actual temperature. So see, at first, when I read it, I was like, hey, you're not going to buy a cheap thermometer. You're going to buy an accurate thermometer. That thermometer is going to give you an accurate reading. And the stated temperature, I thought that was like a weatherman like Kevin Orpret saying, okay, here's my estimate of what I think the temperatures are going to be. Well, now that I've read this problem again, I misinterpreted it. It was a slight misinterpretation. I still had the same values, but I think that I referred to these as stated and not actual temperature. Let's do the next one. All right, so we have a machine is used to fill bags of potting soil with 9.6 pounds. After the bags are filled, another machine weighs them. If the bag weighs, that's misspelled, weighs 0.36 ounces more or less than the desired weight, the bag is rejected. Write an absolute value equation to find the heaviest and lightest bag the machine will approve. Okay, so let's let x equal the true weight of our bag of potting soil. Now, we want it to be, ideally, it's going to be filled with exactly 9.6 pounds. But we don't have enough money to purchase a machine, say, that fills it with that accurate. Like the thermometer, there might be some inaccuracy in our equipment. Our thermometer, it was good at reading the temperature, but not great. It can sometimes be off 1.5 degrees below or 1.5 degrees above what the true weight is. And for some reason we said exactly that rather than like an inequality. But anyway, here the same thing. We're going to say that it's exactly 0.36 ounces off of this target weight. Okay, this true weight. So let's solve this inequality to get our min and max. X minus 9.6 is equal to negative 0.36, or x minus 9.6 is equal to positive 0.36. So let's use let's use a calculator so I don't make a silly mistake. So I've got 9.6 minus 0.36 for 9.24, and that's in pounds. And this is 9.6 plus 0.36, and 9.96 pounds. All right. So, yeah, the heaviest and it doesn't want to range. It's not yet. See, soon the wording will be such that this won't be an equal statement. It'll be an inequality. A less than or a greater than or equal to. So we're saying that if it's 9.24, let's see, 9.24, hey, even though it might upset a customer because you're truly getting a little bit less than what you paid for, it's not enough that they're going to stop buying our product because they realize, hey, you can't be NASA accurate, like with the space shuttle or something. Or if it's a little bit extra, then hey, they're definitely not going to complain. They got a little bit more than what they paid for. So there's my answer for number 4. Let's do another one real quick here on the same video. Machine fills boxes with 15 ounces of cereal. After the boxes are filled, another machine weighs them. If the box's weight differs from the desired 15-ounce weight by more than 1.2 ounces, the box is rejected. So this is the exact same idea. These problems are identical problems, even though this is potting soil and this is cereal. Look at it. You've got one machine that's filling the bags of soil. This machine is filling boxes of cereal. You've got a machine that weighs and determines the true weight. You have a machine that's weighing the true weight of the cereal. So let's let X be our true weight, not the weight that the 15 ounces that's stamped on the box of the cereal. This is the true weight in ounces. Okay, so our target is 15. We want 15 to be in the middle, and if we're more than 1.2 ounces away from that middle value, we're going to reject it. So we've got two equations. X minus 15 is negative 1.2, or that X minus 15. We know how to solve absolute value equations. Let's add 15 to each side. is that 13.8? And is this 27? And these have units of ounces. Okay, so that makes sense to me then. If the lightest acceptable, if we're at 13.8 ounces, we're going to send that box of cereal out to be sold at the store because I guess we're assuming that maybe it'll upset a customer, but not enough to truly affect our sales. That they're going to be forgiving, that that's close enough to the 15 that either they won't even notice it or that they'll be forgiving about it. That the 27 ounces, um, 1.2. I was like, man, that's a lot. When I added when I wrote that down, I didn't the decimal I didn't write down. All right, so if we add 15 and 1.2 is 16.2. Sorry about that. Boy, somebody be like, man, I only wanted 15 ounces of this. I didn't want this much. I guess they might not complain because it's the same as a 15 ounce. So if they get 16.2, excuse me, 16. I didn't want to cough in your ear there, so I had to hit the pause button real quick. I have to do that sometimes frequently. So this is the lightest they'll be accepted, and that's the heaviest they'll be accepted is what I'm trying to say. So there's our answer. So I'm going to put other solutions on another video. So I hope that helps.